Hello and welcome back to the Dragonfly Daily, your source of new content every day on how to deal with image processing challenges and how to do it in Dragonfly. I am your host, Mike Marsh, the product manager at Dragonfly. You can follow me at Dragonfly Wizard on Twitter. You can also find me on LinkedIn and ResearchGate, but please visit our YouTube page where you can view all of these videos and lots more of content on how to use Dragonfly and how to solve image processing challenges. A note on this week's schedule. So today is lesson 20. We will be talking about that in just a minute. We'll have a lesson on Tuesday, a lesson on Wednesday, and then we'll have no Dragonfly dailies on Thursday and Friday. However, we strongly encourage you to register for the CCEM workshop. If you visit that link you see here, ccem.mcmaster.ca/outreach-and-events, you will visit this webpage. Oh, I can't find the webpage. Well, that's all right. When you visit that webpage, you just scroll down just a little bit and you'll find the information on the workshop on image processing for electronmicroscopy. We'll be giving a lecture, a 90-minute lecture on Thursday and another 90-minute lecture on Friday. Thursday's lecture will be on how deep learning obviates image processing needs in many cases, and then Friday's lecture will be on the segmentation wizard, which uses both the techniques you'll see today for Segmentation Trainer and the techniques for deep learning all integrated into one solution. So catch those webinars if you want more Dragonfly content. As I say, today is lesson 20. The topic is Segmentation Trainer. This was requested last week. People said they want to hear about Segmentation Trainer, and so we'll give it to you today. If you're watching this on YouTube, hit that subscribe button. More subscriptions, more likes. No one gave me any likes on the deep learning videos, so you know what? Maybe we'll just put those on hold. I really wanted the likes, and you guys are letting me down. I like all the live content, so keep joining live and keep giving me questions, but please visit YouTube and give me some likes. Now, all of last week's lessons were on deep learning, so we had one theoretical lesson and then 4 practical lessons spanning the applications of image segmentation, denoising, super resolution, and then some advanced topics. I do want to give a big shout out and thank you to our programmers at the home office who worked specifically on these topics, specifically on work on our deep learning engine, which was initiated by my colleague Ruslana, who really put together the framework for how we were going to handle deep learning. And then a lot of the heavy lifting was done by Benjamin, who has really been our applications genius and then continued to evolve the user interface, but also evolve the infrastructure so that we can handle a number of diverse models. And then speaking of models, my colleague Emimal was responsible for adding a lot of the models that we have in Dragonfly. So we have not just UNet and DenseNet, we have about 20 different models, and a lot of those are available at the Infinite Toolbox, but you can also ask us and we can send those models. And a lot of, pretty much all of this work was done under the direction of Nicolas Pichet, our Chief Scientific Officer. So a big shout out and thanks for those programmers working on the deep learning engine. Really, I'm so happy with the deep learning engine in Dragonfly. Everything we talked about last week is going to be applicable, really, whether you're doing deep learning in Keras and TensorFlow, or whether you're doing it in Dragonfly or some other application. But because of the effort that my team put in, I think we've made substantive advances and gotten there first, and we really think you're going to see the deep learning capabilities that you have in Dragonfly are going to give you an edge over other tools. So we encourage you to use it, and we thank you for your support. Now, Lesson 20, Segmentation Trainer. Today's lesson will be carried out in Dragonfly 4.1. Last week, we were talking about different topics, and people said, hey, can we hear about Segmentation Trainer? And I hadn't written a lesson plan for lesson 20, so here it is. We will talk about Segmentation Trainer today. Segmentation Trainer is a tool. It is a machine learning tool for image segmentation, and here's some of the things about it. You can use one or more input images. So much like the deep learning engine, you can have, for example, a secondary electron and a backscatter electron as your input signal for trying to learn how to do the segmentation. Or if you're doing X-ray CT, you may have a low energy scan and a high energy scan if you're doing dual energy. Your output can be either an ROI or actually it has to be 2 or more output ROIs. So when we looked at deep learning last week, the target output for a multi-label segmentation was a multi-ROI. So Segmentation Trainer is a little bit older, and we had some different architectural decisions. Starting with the next version, the behavior of Segmentation Trainer and the deep learning engine will converge, but in 4.1 it's slightly different, and so here you'll have to use 2 or more ROIs as the output. You are able to tailor the idea of the feature vector, and what we'll see here is that you can use different image filters to try and determine which pixels should belong to ROI A and which pixels should belong to ROI B. There's a lot more training, or I should say a lot more tailoring and customization done here than in the deep learning engine. So in our opinion, the deep learning engine really subsumes the segmentation trainer because it can do everything you could do in the segmentation trainer, but it learns the feature vector for you. But you might still want to use the segmentation trainer. One advantage is it can work on both pixels and superpixels, which we'll see today. Another advantage is less training data is required compared to deep learning. So you'll see that while you are doing training with Segmentation Trainer, you have different machine learning models that are supported, for example, Random Forest, Adaboost, and others. You'll also note that training is not cumulative. We made a point of emphasizing last week that when you do deep learning, unless you reset the model or create a new model, every time you do training, it is training on top of a trained model. That is, it is learning the weights, but it is incrementally changing the weights in the network over the last version. Today, with Segmentation Trainer, you will note that every time you train the model, it's completely retraining the model. So it's not a cumulative training process. And like with the deep learning models, these Segmentation Trainer models, they can persist on your machine. You can use them whenever you need them. They can also be shared and retrained with other data. Now let's hop over to Dragonfly 4.1. We're going to look at two data sets today. The first, well, which one do I want to do first? Let's do the mixed wet carbonate first. So this data set is available from the Digital Rocks portal. Oh, not that button. I want to do import image files, and I will find the raw file here. Here it is, sample2 raw, and I'll click next. This data set can be found on the Digital Rocks portal. Let me go ahead and input it, and then if I have time, I'll switch over to the Digital Rocks portal so you can find the specific data set. In this case, the image dimensions, or the matrix dimensions, are 976 by 1014, and it is unsigned short, and then the final dimension is 601 in the Z. As you scroll through here, you can see this. What we're looking at is a carbonate, and then in the pore space, it's either filled with oil or brine in this saturation experiment. I did not make a note of which of the phases in the pore space is oil and which is brine, so I'll flip a coin and make it that wrong when we do the interpretation. Now, after you input the matrix dimensions and you identify the data type, you can click Next. On this page, I'm going to indicate that it's 2 microns per pixel in each dimension, and I'll call this my mixed wet carbonate. At that point, I'll go ahead and hit Finish. It's going to load the 1.1 gigabyte data set. So here it is. Now at this point, I will see if I can pull over and get you to a, by the way, just a note, here's where you want to go to register for the workshop for Thursday and Friday. Now, the data that you want here, Digital Rocks portal, we're going to look at 2 data sets today. So let's go to the portal. We'll go to Browse Published Projects. The first data set I'm going to look at is, well, I don't know the search string. I know it's near the bottom. It's an Imperial College data set from Amer, and it will be labeled, I think, Wetability. Oh dear, I can't find it. Let's see if I search for Wetability. Do I find it? I can't even see where my search is lighting up. I'll search for Imperial College, see if that helps. Those guys have contributed a lot here, and you know what? I can't find it, and we'll come back and look for it later, because once I pull up the attribution, oh, you know what? Here it is right here. So this is the data set. I am looking at sample 2, this data set right here. So if you want to grab it, you can download this file. This is the file I'm opening right now. The next data set I will look at after this is the FIBSEM data set from Matt Andrew at Carl Zeiss Microscopy. So Matt's data set is on this page as well, and it's the Vaca Muerta shell, or shale. So it's a mud rock from that South American formation. And if I search for FIB, I might find it. Here it is. So the second data set I will load today is this image data set right here. So you can download this, which is 2.5 by 2.5 by 5 nanometer pixels. All right, those are the 2 data sets. So starting with this data set, as I mentioned, this is from Amir Alamedi and colleagues at Imperial College. This is hosted on the Digital Rocks portal. This particular data set is sample 2 mixed wet carbonate. Now, in Dragonfly, if you want to do image segmentation, we saw a whole host of lessons on segmentation where you can use ROI Painter and ROI tools. Today, we will use ROI Painter and ROI tools just to create a few seed regions for prompting the Segmentation Trainer to learn the different phases. So what we will do is we'll create some ROIs. So I'll create a new ROI, and we'll call this oil, and we'll create another one, and we'll call it brine, and I'll make the brine blue, and finally we'll make and click OK, and then finally a third material, and we'll call this carbonate, and I'll make that orange. All right, good enough, and OK. Now, what I can do is I can paint a little bit. So I can paint a little bit of carbonate pixels. So yeah, there's some carbonate painted. That's all good. And you see here two different phases. So let's suppose for a minute that the brine is the one that's attenuating X-rays less. I don't know which one they actually added the dopant to, but let's say we call this the brine, and we paint a few pixels of brine, and then we paint a few pixels of the oil. So we'll go in here and we'll paint a few pixels of the oil, and we'll try and paint the pixels that we think are unambiguously oil. And there we are. We've painted a few reference pixels. Now I can go into Tools, Segmentation Trainer. Now note that this painting, I can interactively do more painting at any time. Here I'll see a list of all the models. So I did a few experiments before we started this. I even created one called Mixed Wet Carbonate. But let's create a new model, and we'll call this model Lesson 20 Mixed Wet Carbonate. And what you do here is you create models. You can identify any information. You can write a description. This is a 3-phase segmentation of grains, oil, and brine in the digital rocks portal mixed wet carbonate sample. So that description will persist if you look at this data, if you look at this model at any point later. Now, there are multiple tabs here. I can go to the Input tab, and I can specify that I'm going to have this data set. I'll click plus, and I'm going to have these ROIs. So I'll Shift Select and do plus. And here you determine the engine. So last week we did deep learning, and all of our deep learning used convolutional neural networks, so they all used neural network technology. This uses a variety of machine learning engines, but not neural networks. So there are different engines, for example, Random Forest or Extra-Cheese Forest or Adaboost, etc. You can find all of these described in scikit-learn. That's the library we're using to make this possible. Random Forest is the same technology you would see if you've ever used Weka trainable segmentation in Fiji, and so we could just use that as an example, although sometimes I like to use Extra-Trees Forest. So on the Classifier tab, we name our model, we put any documentation we want, and then on the Input tab, we input we determine how many image inputs, so in this case just one grayscale image, and how many segmentation targets. Then under Features, what we can do is we can say, well, I think the intensity is a signal, so I'll add intensity associated to that input, and maybe I want to look at different signals, so difference of Gaussians, and maybe local extrema, and maybe a median filtered version of the data locally, and maybe the morphological. So I'm saying all these terms and they don't mean anything, and that's one of the trade-offs of Segmentation Trainer is it's highly customizable, but you have to know what these different things are. If I mouse over any one of these dataset features, you'll see a list of image filters, a dilate filter, a close filter, a morphological gradient filter. If I go to Otsu, you'll see the Otsu filter. So these are sets of filters, are filter banks, and I can attach all of them to this data set. And so you get to decide what image filters you think are going to help discriminate the brine from the grains from the oil. And so you can put in spatial filters and intensity filters, etc. And then whenever you hit train, it's going to take all of your training data and it's going to run filters on those pixels. And then it has this parameter hyperdimensional space where it's going to try and find some sort of hyperplane. That's a bit of an abstraction, that's not really what's happening, but try and find some hyperplane in this high dimensional space that'll differentiate the pixels that you've labeled blue from the pixels that you've labeled orange from the pixels that you've labeled green. So this can be very slow depending on the different image filters you've chosen. So we'll see if this plays out. Hopefully I haven't burdened it down where it locks up. So it's already trained the model and now it's going to extrapolate. So this is the result of the model. I can go to the final tab, which is result, and we can see, okay, so we see what it's labeled as grains. We see that it's labeled pixels like this as brine, and we see what it's labeled as oil. Is this right? I don't know. I don't know what the ground truth is. I think it's not right, and I think what's happening here is, for example, these pixels are in fact grain and these pixels are oil, but it's mislabeled. Did I go to a different slice? I can't find my segmentation. But it's mislabeled these as brine. So I could add segmentation. Let's go back to that slice. I could add segmentation of here in the oil. So for example, I could choose the oil and I might turn on this, and if I paint this, then I have a few more oil, and if I paint this, I have a few more carbonate. Whoops, don't want to include that one. So it is a very good idea to include edges. So if you segment all the way up until the edges, then your segmentation has better training data. So just a little bit like that might make the model improve a little bit better. Now, if you're working in this space and you really don't know anything about these image filters and you don't know which ones to choose, well, you could choose different ones and based on our suggestions or by guessing, and you can look here and see which of the image filters actually has a higher weight in the final answer. And if you have a good answer, then maybe you just delete some of the ones with small weights. If you don't have a good answer, you may add more and see if you get some more contributing to a better segmentation. However, all of that's very tricky, and that's one of the limitations of this method. Now, I could remove all of these, and then I could use a special tool here called Activation Map 1 and 2, and I can add this to the data set, and we can train again. Now, Activation Map 1 and 2. Recall last week when we talked about deep learning, especially in the first lecture that we gave the theoretical background, we told you that deep learning is a process of recognizing patterns and then assigning them to a label, and those patterns are aggregated based on features. Well, if in the early layers of a deep learning network, it builds and customizes convolutional kernels which give it some feature signal, and then in the next layer it aggregates those into the early patterns. What you can do in Dragonfly is you can use those self-learned patterns as your signal for the segmentation trainer. So we have provided the activation map 1 and 2 from a large class of scientific images, and you can use that. And so it is not programmed by programmers. It's determined by a deep learning model to be highly differentiating features. Now, it's not trained on this data set. However, you could go over into this data set and train a deep learning model, and then you could extract out this activation map and add it as a possible data set feature here. Now, if I go over to the result tab, we can see how good a segmentation did now. Okay, so not a great job, but you can kind of see where it's going. So we could provide more data, we could tune with more parameters. Now, I'm going to switch and look at a different data set. And by the way, whenever you have trained the model, you can always go to a different slice. You can zoom in and hit preview, and it will apply that model on the local space. Now, the model's completely trained. It doesn't take that many minutes or hours like a deep learning model. It's a much simpler mathematical model to train, and you can evaluate these results interactively and look at different models and see if you like the answers. So we're going to move on to the other data set. So over here on classifier, I do have my less than 20 mixed wet carbonate, and it is trained and it is available. I don't have to hit save. It's already saved. Now I'm going to close out this data, and I'm going to load up a different data set. So let's look at the Vaca Muerta shale. So I'm going to go to File, Import Image Files, and I will scroll down to the bottom of the list. Here it is, Vaca Muerta, and I'll click Next. And in this case, it's 0.0025, 0.0025, and 0.005. So 2.5 nanometers by 2.5 nanometers by 5 nanometers, and it's this Vaca Muerta FIBSEM, and I'll hit Finish. All right, so that data set is, what did it say, a couple of gigabytes, so we'll go ahead and let that data load. All right, I am having a refresh error, so let's see if I'm going to right click, and I'm going to double click. That data set is not in my workspace anymore, but it's there's a bug that's causing it to still be refreshed. What if I go here and choose a different view? I'll close this out and go back, and we'll turn this data set on and refresh. Let's see if that does it for us. Now, in this data set, we can look and we can see multiple phases. We have an organic matrix, we have pore space, we have framework grains of at least 2 different types, and then we have our pyrite grains. So we could build ROIs for each of those. So I can once again create a bunch of ROIs. So here's a new ROI. We'll call this the pores, and then we'll create a new ROI, and we'll call this the the silicaceous grains, and then we'll create another one which is my other grains, and then we'll create one more for organic. That green is a little bright, and let's make it a little bit darker, and then we'll do one more for the pyrite, and maybe we'll try and make it kind of gold, whatever. Okay. All right. So let's do this. Let's paint some of these grains. So let's use the ROI painter to paint some reference pixels. So I'm going to go to the circle painter, and I'll start with my pyrite. Now, remember what I said about capturing some of the edges. So we'll do this, and this will help me capture those edges pretty quickly. And there we go. We have one reference pyrite grain painted. Now let's go to the bulk grains, which are these guys. You know, get some of these grains painted. We'll zoom out a little bit, get some of this. I don't like that, so whatever, just paint some pixels here. Then we'll paint this other grain. Where was it? It was a little bit darker or a little bit brighter. Oh, maybe this grain. Is that it? Oh no, this grain is so much brighter than the rest. So we'll call that a different grain. And then we'll do some of the pore space. So let's zoom in and get some pores. Boom, boom, boom. And get this pore. And then we want to get some organic material while we're here. So all of this that's not pore space is all this organic matrix, and we'll just call it that. All right, so we have some of these training materials painted, and that's it. And we just go through the same pattern. So I go back to Segmentation Trainer, and I want to create a new model. So, and I trained one last night, so if you want to see how it went, I could just go to Veka Muerta Shale, and I could import this data set. Oh, I trained one last night on 2 different data sets because I trained it on the secondary electron and backscatter. But right now we just have this one processed data set that's available on the Digital Rocks portal. Let's just go ahead and create a new model, and we'll call this one Lesson 20, Veka Muerta, and we'll go over to Input, and we will use this as the input, and we'll use this as the targets. And all right, so I have all of those materials. And I'll save myself a lot of time just by using this again. So now it's associated with that data set. I should note here that if you have multiple data sets, you can have different feature vectors or different filter libraries associated with each of the different data sets. So if one data set is more about shape and one more data set is more about intensity, then you can choose the right filter banks to associate with each data set. So there we are. We've got some preliminary data used for training. We'll go ahead and hit train, and we'll give it a minute to evaluate those activation map 1 and 2 on all of the trained pixels, and then try and come up with a extra trees learned model that can segment all these different phases. So, oh, I'm so sorry to say we're not seeing the captions. So can I go back here and go back to my slides, go back to present mode and captions, and sorry about that. All right, captions are underway again. So you do get captioning of what I'm saying even when I have nothing to say. So we're almost done with the training of this model, so we'll have a look at the results. It will apply a preview over the entire field of view, and the model is trained. The model is trained. It can be used at any point after this. Anytime you hit train again, it will overwrite this model. So it is not cumulative. It is retraining based on the new parameters. Now, I don't see any results, and that's because if I went over to the result tab, maybe I just have to wait. It's still processing. So when it comes back, we'll go to the results tab. We'll look at the slider so we can adjust the opacity of the preview. Okay, I don't know if it's locked up or if it's still thinking. So I'm going to go over to questions and answers, and if it comes back, we'll look at the result. If not, then, we'll just, we could close Dragonfly and load it back up again and see if the model is ready. All right, so as we mentioned today, you can use 1 or more input images. You can have 2 or more, you have to have at least 2 or more regions of interest, and you can tailor the feature vector. So it's quite different from the deep learning engine in that you have to specify the signals that get used to interpret the image, but it's more generous than the deep learning engine in that you can get away with less training data. So that covers what we wanted to cover in today's lesson. We can now look at questions and answers. So we'll start with the first question, which was from the top of the hour. Will we do a longer Movie Maker session? I like the one we have, but showing how to use clip function for different ROIs might be helpful. We can certainly revisit Movie Maker. We won't do it this week. I haven't planned anything for next week. But by the way, if you are listening right now, the lessons for this week will be on quantitative analysis. So we should be looking at slice analysis and objects analysis in the next 2 lessons. So maybe next week we can revisit Movie Maker. Like I say, I haven't planned the content for next week. Next question. You gave likes. Thank you very much. Please, let's keep giving likes on the YouTube videos. Next question. Will the webinars from the workshop on Thursday and Friday be posted on the YouTube channel? I don't think so. I have not talked with the organizers at CCEM. I don't know if they're being archived and if we're allowed to repackage them and put them on our YouTube channel. I will find out. So, Nicola, if you can take a note and reach out to our colleagues there and see if we'll be able to access those recordings and post them on YouTube. Next question. Acquiring high-resolution images with Scout and Zoom gives me an image with larger dimension compared to the low-resolution image of that part of the object. How can I use deep learning for super resolution and take the input and target with two different dimensions? So, yes, so for super resolution, you have to have a model that specifically has a different matrix dimensions for the input and output. And the model will have to be a specific integral scale up. So 2 times the dimensions in X and Y, or 4 times, or 5 times, or 8 times. So you will have to have a specific scale up. If you have used Scout and Zoom and you've gotten something imprecise like 2.2 instead of 2.0, you can resample either the low res or the high res, and that way you can get a scale up that is an integral number. So I did mention at the beginning of today that the matrix dimensions have to be the same, but that constraint, the input and output matrix dimensions having to be the same, is not valid for super resolution models. In that case, the matrix dimensions have to be a scale of 2x or 3x. If you want to use super resolution models, you can certainly email support and we can send you a super resolution model. I don't know if we have any on the Infinite Toolbox right now or not. However, starting with Dragonfly 2020.1, there is a special super resolution wizard that sets everything up for you and helps you create a model specifically for your data. Next question, does Segmentation Trainer use the GPU? The answer is no. The Segmentation Trainer is using, as I mentioned, the scikit-learn libraries, and those are executing on the CPU. Next question is, the subtitles failed once you went to the digital rocks. Yes, I didn't notice. Sorry about that. So they're back now. Next question. When would you use Segmentation Trainer over deep learning? That's a great question, and that's why I actually didn't plan to cover it at all until people asked me to cover it, is I always turn to deep learning. However, maybe there are some scenarios where you would like to use Segmentation Trainer because you can get such great results with such little training data. And in fact, that is the whole goal of the segmentation wizard. So what you'll see if you tune in for Friday's lecture is we've integrated the tool, so when you go to start a new segmentation, you're able to start with a segmentation trainer scenario where you just paint a few pixels here and there. It creates a quick model, and then it makes a prediction, and then you can fine-tune and edit that prediction so that you now have input for deep learning. So you can bootstrap your way up to having lots of training data without spending lots of painstaking time painting a full slice or a full area from scratch. I'm going to look over and see if okay, it did come back. I don't know why it took so long to come back. Those results don't look very good, but let's look and see what we got here. Okay, so there's a lot of noise that it's trying to interpret here, and it is, well, we didn't give it great segmentation training in the organic phase, so it didn't do such a great job. So I could have spent more time on it and given it more training data. Of course you saw that I just painted a few pixels here and there of the, and I can't tell right now if that's pyrite or the silicaceous grains because I didn't give them a very distinctive color. I guess if I do a larger area and I do a preview, then we'll see the color difference in the pyrite and the silicaceous grains. All right, back to the questions. Segmentation Trainer is an unsupervised learning. Choosing features is actually feature engineering here. It is supervised. I mean, it's supervised in that you are giving it a segmentation target. So it's considered supervised learning because you're asking it to learn from your example. And so the feature engineering is happening here because you are choosing which filter banks to use. All right, how are we doing on time? All right, next question. Where can we find out more about the dataset features, which ones to use and what they mean? So you can mouse over any of them and see exactly what filters are being used, and then you can look in the Dragonfly help pages to see, oh, what is a Gaussian filter? What is a median filter? Furthermore, you can create your own feature or filter banks just by aggregating them together. You will see in the Dragonfly user interface, I can't show it to you right now because it's still taking the existing model to classify this entire slice. But in the user interface, you are able to create your own, well, you can edit the filter banks and you can create your own filter banks. Next question, what would happen if the ROIs have an overlapping area by mistake when you run Segmentation Trainer? I do not know. I suppose the second one listed would be taken and the first one would be ignored, but we would have to dig into that. So be careful, because with this model, your ROIs can overlap, and that's certainly a nonsense input. Next question, I'm really astounded and disappointed by the YouTube engagement by live audience numbers. It sounds to me like YouTube is how Mike's success is measured, and we, our listeners, are not coming through. Well, thanks for the encouragement. We would appreciate lots of likes on the YouTube channel. We want those videos to float up and be at the top of people's search queries when they're looking for demos or examples or image processing, and YouTube is prioritizing those based on number of views and likes, so we could certainly use more engagement. Please share those videos with others who are not attending live. Next question is, have you tried the image segmentation trainer using secondary electron image? I asked as there will be no contrast in the image of grains. I'd like to know how it worked with secondary electron image. Well, it actually, so let's look at what we have here. Okay, so this mistake in the organic is actually with the I want to say the quartz grains, but I don't actually know. I just call them the silicaceous grains. It's not with the pyrite grains. We can see the result there. Now, I actually have these data loaded. If you want, what I'll do is I'll pull those off my disk. So I'll do import image files, and I'll just load the first 100 slices of the SE2. So let me hit Control A and next, and these, doesn't matter for this, but these are 5 nanometers. And I will crop and I'll just grab slices 401 to 500 and click OK. So this is the secondary electron image, all right? And I'm going to tell it to, or it's the SE2 image, I'm going to tell it to import another data set with the same geometry. And this time we'll grab the backscatter image. So we'll go here and do Control A and next, and again 5 nanometers. And this is the energy selective backscatter, and should use the same slices. So we'll pull that in. Yep. And what we'll do is we'll look at these data. Let's go here, and all right. So here's the backscatter image, and here's the secondary electron image. Now, I did make a model yesterday, so let's see. If I come to Segmentation Trainer and I switch and I choose the model I made yesterday, and as input, gosh, I don't remember which one was the secondary electron and which one was the backscatter. So if I choose the wrong one, we'll get terrible results. And then we could just ask it to do a preview right now and see how it goes. If it gets the bad results, I'll swap the inputs. But yeah, so obviously the backscatter has good Z contrast and the secondary electron has good edge contrast. So it's working on this entire field of view. We'll see if that comes back before I finish answering questions. All right, next question. Could you please put the link here to papers published using Dragonfly? Wow. I don't have all the papers published using Dragonfly. I would love to collect that. If people will email collaborate@theobjects.com, I will take all of your submissions and we'll promote them here so people can know what's been published using Dragonfly from the users, and I will add to that all the papers we've published. We publish most often at M&M, which is the Microscopy and Microanalysis meeting. It is peer review. It's not a very stringent peer review. We just publish 2-page manuscripts we're able to present to the community every year and show what's coming new. Oh, I should mention we have 2 talks at M&M this year, but M&M is going to be a little different this year. It might be fully virtual or half virtual. But please, if you do have papers you want to share with us, and I mentioned last week I showed 4 different papers, 3 printed and 1 submitted on deep learning with Dragonfly, and there's others out there that have been done on bone. And there's we only showed 1 of Sydney's papers from PUC Rio, and he has 2, so there's a lot of good stuff coming out with Dragonfly. Next question. One would think that the number of registered users would give an idea of how important and how valuable the webinar series is. Well, the registered users does not correlate with the number of people viewing. It doesn't correlate very directly, so some people register and then only attend some webinars. So we really want those metrics on YouTube. And as I mentioned earlier, the YouTube data is valuable. The YouTube likes are valuable because that will help rank the videos higher when people are searching for it. Next question, with regard to OpenPNM, I have a CT of a 3D printed item with regular pores. Segmentation appears to do well identifying them, but when I use OpenPNM to generate a multi-ROI, not all the pores are labeled. What am I doing wrong? I don't know. So I don't have any expertise in giving guidance on OpenPNM. That is one of the things we want to cover probably about 2 weeks out, is cover an application series where we do bone analysis and we do CT reconstruction and we do maybe FIBSEM reconstruction and then also pore network modeling. So I'll have to learn how to do it before then. Until now, you might see if you can get support directly from the authors of PNM. That is Jeff Gostick and his colleagues at University of Waterloo in Toronto. So those are the authors and contributors. I think it's in Toronto. Those are the contributors of OpenPNM, and it's their tools that are being integrated into Dragonfly. Now we'll look back over to this. It's still computing, so we won't be able to see the result now. So those are all the questions and answers for today. Thank you for your patience. Thank you for your interest. Please check out the videos on YouTube, and we'll be back tomorrow with quantitative analysis, with objects analysis, I think maybe objects analysis, and then slice analysis. I don't know. You'll have to tune in to find out what order we cover those in for Tuesdays and Wednesdays lectures, lessons 21 and 22. Thank you. Stay healthy. Be good to each other, and we'll see you tomorrow. Take care, everybody.